For our last unit, really, we're looking at components of Chapter 8 and Chapter 9, which we are basically looking at patterns and how we can develop our own formulas and rules for patterns. And then in Chapter 9, we're going to be looking at the beginning of statistics with permutations and combinations. It's going to be a lot of pattern work, really, which is kind of fun. That's really what math is built off. We notice patterns, we put numbers to them, we have lots of applications from them. Some new words that you might be hearing, I don't know if you've heard these before, we're going to be looking at sequences and series. A sequence is simply a set of numbers written in a particular order. So let's write that definition and then I'll just show you an example of what that looks like. A sequence is a set of numbers written in a particular order. Here's an example, probably one of the most basic that you've seen before, listing out the numbers 2, 4, 6, 8, 10, etc. That's an example of a pattern. It's a set of numbers, and if we're looking at what is the particular order, what's happening to each number to get to the next number? Yeah, you're adding 2. 2 plus 2 is 4, plus 2 is 6, plus 2 is 8, plus 2 is 10. So our goal is going to be eventually to just see, hey, if I wanted to find the 30th term, what would I do to that term to find the number that will exist? Now, a few other pieces of notation. Each of these numbers, they have a name. The first number is called A1. So when you see this little notation, this represents that term. So the little 1 subscript means that 2 is the first term in the pattern. So A1 represents the first term. So if I was looking at the 4th term, if I'm trying to find A sub 4 or A4, what would I look to in this 8? Yeah, I'd look to 8. So 8 would be the 4th term is equal to 8. So what that implies, if you see an A sub n, n responds to the, or corresponds to the number term. So let's go ahead and let's just put that this labels each term. Labels each term. And then our ultimate goal is going to be to find the formula that would exist for each term. So the formula for this particular pattern, actually you guys might already be able to figure out what it is. But if I look at this as the number 1 term, this as the number 2 term, this as the number 3 term, this as the number 4 term, what's happening to the number term to get the particular element in the pattern? Times it by 2, exactly right. So what Olivia just found is she found the formula. We would say that any term for this particular pattern is equal to 2 times, oops, I meant to do that in a different color, 2 times the value of n. So when you see just kind of terminology like this, this represents the formula for the formula to find each term. And that's going to be like just a fun goal for this chapter. So, and we always want to check to make sure that it works. So, for example, in this particular pattern I've given you, I've only given you 5 terms. But once we know the formula, it's powerful, because if I wanted to find the 30th term, rather than adding 2 30 times, once I know the formula, I would just plug it in. N corresponds with 30. So what would be the 30th term? Yeah, exactly right, 60. 2 times 30. Okay, so our first goal of action today is just to work with this new notation, and then at the end of the notes we're going to see if we can construct the formula, and as these get more complicated we want to be able to identify the patterns that will help us. So using that new terminology, it says find the first 4 terms and the 20th term of the sequence. So for example, if I'm finding the first term, I'm looking at A sub 1. What's the value of n? 1. So I'm looking for 1 squared plus 1. And what's the answer? What is the element of the first term? 2. 1 squared is 1, plus 1 is 2. Then if I'm looking for the second term, what's the value of n? 2. So I have 2 squared plus 1. That tells me that the second term is equal to 5. If I'm looking for the third term, the value of n is 3. So that would be 3 squared plus 1. 9 plus 1 would give me 10. If I'm looking at the fourth term, the value of n is 4. So I'd be doing 4 squared plus 1, which would give me 6, exactly right. And then how would we find the 20th term? Plug in 20 for n, exactly right. So the 20th term would be plug in 20 for n, and we have 20 squared plus 1, and that would come out to be 401. So the pattern that we're looking here is 2, 5, 10, 17, ... And then the 20th term, a sub 20, would equal 401. Okay, that's what we're looking at. I know the beginning, the intro, that's why we only have 15 minutes for this lesson. It's just the intro of what types of things we're seeing. So with your partner, why don't you just make sure you guys understand these new terms and solve number 2 together. Solve number 2. Okay, so as you can see, you can plug these numbers in and find the elements. First term was 1/2, second term negative 2/3, third term 3/4, fourth term negative 4/5, 20th term was negative 20 over 21. Now before we move to the next example, what did this guy do to each element? Why did they have negative 1 to the n plus 1? What happened when you started working algebraically with that? Yes, this created every other term negative. It made the first term positive because when we plugged in number 1, it made negative 1 to an even power. And then the next term negative because then it's raised to an odd power. The next one positive because then it's raised to an even power, and the next one negative. That's a really important piece to identify because it's going to show up in quite a few of these patterns. Okay, now with that said, let's move to the very last example. This is just probably the most challenging aspect of it. Now, we're not given the formula. We're not analyzing what those little pieces mean. We have to create the formula. So the best thing that I would suggest to do is to just take a look at what's happening at each value of n. So if I look at the first term, this would be n, ooh, that's a weird color. This would be n is equal to 1. This one would be when n is equal to 2. This one's when n is equal to 3. This is when n is equal to 4. And this is when n is equal to 5. Now, disregarding the negatives, just for the time being, do I see any pattern that's occurring with the actual element or the actual term? Probably shouldn't call it element. I think it's called term here. But with the actual term and the value of n. Can we see anything? Alex? N divided by 2? Well, that would work. You're saying when n is equal to 1? Oh, I see. Then that's 1/2. When if n is equal to 2, though, if we divide that by 2, that would give us 1. It just wouldn't give us that second. But you saw a pattern with the first thing. That's good to start looking for. But we want to make sure it works for every value of n. Maggie, do you see something? By negative 1/2. So negative 1/2 times, you're saying oh, okay, so you're seeing what's happening to each term. Okay, that's good. But what if I want to find the 100th term in the sequence? I want to have a formula. So you're good. You're seeing the pattern. But I want to create a formula that would generate, like, what would be the 100th term. So I'm looking for what can I do to the value of n that would give me an easy way to evaluate the 100th term. Katie?
Isn't it 1 over 2?
Excellent. If I look at it in this way, 1 over 2 to the first power, I can see how that brings in the value of n. And if I look at the second term and I analyze it as 1 over 2 to the second power, that brings in the value of n. And then looking at the third term, I have 1 over 2 to the third power. That brings in the value of n, because this represents the value of n being 3. Bringing that home, this one is 1 over 2 to the fourth power. That brings in that value of n as 4. And then last but not least, I know you guys, excellent. So you are looking, I said disregard the negative just for the moment so we could see the pattern with n, but you're right. We do now have to take into account that every other one is negative. So using what Katie told us, we know that each number is 1 over 2 raised to the nth power. But now we have to see how can we make every other term negative. Alex?
This is negative 1
You're saying negative 1 raised to the power of n, just like that? Yeah. Negative 1 to the nth multiplied by that would create this. Well, n plus 1 would make the second term negative. But to make the first term negative, no, it's good to look at. To make the first term negative, Alex is right. We're going to want to just keep it to the power of n. Probably. I haven't looked at one like that. I don't know. I'd have to actually do it out. But the ones that we generally look at is like this one's negative or the second term is negative. But so this is the formula for this particular pattern. But then I do want to just kind of carry that over. What if we had this pattern here? What if it changed to be 1/2, then negative 1/4, then 1/8, and negative 1/16, and 1/32, ... How would that change our formula to find the nth term? Yes. If we take negative 1 to the n plus 1, that will make every other term negative, starting with the second term, and then over 2 to the nth power. Good stuff, right? Yeah, we're going to do more and more and more of these tomorrow. I have great news.